Ooh, I'm rubbing my hands if you can hear that. You know why? Because I'm pumped. I'm ready to evaluate our machine learning models, or see how they go. See how each of these models, using the function we've just created in the last video, see how logistic regression goes, k-nearest neighbors classifier and random forest classifier goes at finding patterns in our training data, and then how those patterns get evaluated in our test data. So without any further ado, let's see how each of these models performs. So we can call our function fit and score, and hopefully it works. And we got here, we see that it takes models, or actually if we press Shift Tab, this is where our docstring comes in handy because it tells us what happens. Fits and evaluates given machine learning models. This is beautiful. This is just like what we've seen with other functions, but except we've created this one ourselves. That's the helpfulness of a docstring, right? So we're going to go here, models equals models, which is our dictionary of machine learning models. We could just go xtrain, xtest, but for completeness, we're going to go xtrain equals xtrain, and then we're going to go xtest equals xtest, and then we're going to go ytrain equals ytrain, and then finally ytest equals ytest. And if we've written a function correctly, what do you think it's going to return? I'll give you a few seconds. Okay, that's enough because we want to see it. If in doubt, run the code. So let's see what our function returns. Okay, so we get some warnings here. What does it say? Stop. Total number of iterations reached. That would require us to dive in. Increase the number of iterations. So this is where it's helpful. Increase the number of iterations, max iter, or scale it down. So this is saying that potentially our logistic regression model could be improved. And to figure out how you could do that, it would require going to the documentation for alternative solver options. But what we're going to do is just work with what we've got so far. So if we have a look at this, this is the score, how each of our models, without tuning, oh, that's a spoiler for what's coming up. This is how each of our models, as the baseline class, has performed on finding patterns in our test data. So it's getting the score here. This is what we're getting back. So if we look at this, which one's the highest? Look at that. Logistic regression coming in as the dark horse, not even on the machine learning map, right? And it's getting the highest score. Well, this might take a little bit of investigation because remember, where are we up to? We're up to experiments, and that's what we're doing here. An experiment is comparing different models, trying different models and comparing them to each other. Now, this is a comparison in a dictionary, but if we wanted to show this to someone, we might compare it visually. So let's do that nice and quickly. We can make a model. Actually, we might make a little heading here. So we go here, model, comparison. Beautiful. So model compare equals, we might turn our dictionary into a data frame because that's nice and simple. So model scores. This is just taking this dictionary here, model scores, and we're going to set the index to be, what does it have to be? It has to be a list called accuracy because that's what this score function here, because our models are all classifiers, their default score metric is accuracy. We saw that in their scikit-learn section. So if we go here, model.compare, we need to transpose it, plot.bar. Boom. Now, I'll just show you why we need to transpose it, because if we did that, it would look weird like that, and we actually want it to look good like that. So this is quickly showing how accurate each of our different models are. And you can see logistic regression just tips out our random forest. And KNN, well, because that's nowhere near the accuracy of our logistic regression model, we're going to say goodbye to KNN. So once we've got this graph, this might be something that we can take to the boss or one of our colleagues and say, hey, look at this. We've built a machine learning model, a beautiful logistic regression model, and it's performed the best. So we're going to use the logistic regression model in practice. And so you might go, I found it. And your boss is like, nice one. What did you find? And then you're like, well, the best algorithm for predicting heart disease is logistic regression. And then she might say something like, excellent. I'm surprised the hyperparameter tuning isn't finished by now. And then you might wonder, what is hyperparameter tuning? Yeah, me too. It went pretty quick. So you're sort of covering yourself here. And then she might say, well, I'm very proud. How about you put together a classification report to show the team and be sure to include a confusion matrix and the cross-validated precision, recall and F1 scores. I'd also be curious to see what features are most important. Oh, and don't forget to include an ROC curve. And then you might be thinking or asking yourself, okay, there's some lot of complex words there. Great. But then you actually say, of course, I'll have it to you by tomorrow. Don't worry, we're going to take care of all these things. We're going to take care of all these things in the next video, because we're still at a point where even though we found a great machine learning model and we've probably shown it to the boss or one of our colleagues and they've gone, wow, logistic regression performing at 88% accuracy, we're still not near our evaluation metric, which is if we come back up the top, which as we said, we kind of want at least 95% accuracy to continue with this experiment. So that's what we're going to be doing, as well as fulfilling all those requests that the boss asked us, just to make sure our model is a little bit more robust than just getting the default score metric. So without any further ado, take a little break, have a review of what we've done so far, and we're going to review some of the things that we need to make sure we do to make sure our classification models are evaluated correctly and are improved as well as possible.